Hello everyone! What's going on? Welcome back to Xcoding with Alvian. Hopefully, everything is going well to all of you. In the previous part 2 of the video, we have explored the list compositional layout and cell content configuration as part of the layout and cell presentation within the modern collection view architecture. In this part 3 of the video, we are going to explore the data part of the modern collection view architecture, the new Diffable Data Source and Snapshot. In this video, we are going to replace an existing implementation of UICollectionViewDataSource with the collection view Diffable Data Source and Snapshot. Let me show you the demo of the app that we will build in this video. We have a list in collection view implemented with the Diffable Data Source and Snapshot. At the top, we have a shuffle button to randomize the data source array and update the snapshot. Notice the smooth diffing animation in the list when the data source changes. And finally, we have a search bar to search the character within the data source. We're going to use Combine PassthroughSubject to publish and observe the text to be filtered using the debounce operator. That's it for the demo. Pretty interesting, right? Now, let's dive back into Xcode to start implementing the app. Before we begin, please download the starter project from the GitHub repository link I provided at the description below. The starter project contains the code from the previous video, list in collection view. The collection view uses the list compositional layout and cell content configuration API with UICollectionViewDataSource. If you are interested to learn more about this, I provided the link to the video at the description below. Okay, now let's open the starter project in Xcode. Navigate to this character list via controller.swift file. Here, for the backing store, I have an array containing the section characters tuple. This is a type alias for the tuple containing the section and the character array. For the section, it is a struct with a single parameter named category. And as you can see, the struct conforms to the hashable protocol. Here, I provide the hasher.combine category to provide a unique hash value for each instance. Also in here, you can see there's a method header title text to generate the section header text given a count parameter. Okay, next let's check the character struct. Here, it has several parameters: ID, name, image name, category, and job. And here, for the hash, I provide the ID to the hasher as the unique value identifier. And also, if you see here, I override this equality check. And for the equality comparison, I compare the ID, name, image name, category, and job between two instances. And as you already know, the Swift hashable inherits from the equitable protocol. I've provided the JSON stubs as the computed property, returning the tuples array inside the universe enum. In this case, I have several universes such as Final Fantasy VII, Marvel, Star Wars. And it will categorize each of the characters into a particular section based on the category. You can see the JSON file in here if you are interested here. So this category property will be used to put the characters into the section. Let's go back to the character list view controller. At the top of the list, we have a navigation bar containing a segmented control where the user can use it to switch between universes. And the character list view controller implements the UICollectionViewDataSource protocol to drive the number of sections and items, as well as providing the character in the collection view cell. Okay, that's it for the starter project introduction. Now, let me give you a short summary about the Diffable Data Source and Snapshot API. Before the Diffable Data Source API was introduced in iOS 13, to drive a table view or collection view, we need to implement UICollectionViewDataSource or UITableViewDataSource. And it's pretty simple and easy to understand. Here we just need to provide a single array or 2D array for multiple section support. And here in the number of section, we just return the outer array count for multiple section, and in the number of items in section, we need to return the inner array for that particular section count. And here, to retrieve the item in the cell for item at index path, we can just retrieve it from the index path section and index path item. Whenever our data store gets updated and we want to update the collection view, we can invoke collection view reload data, or if we want to animate the difference, we can use the collection view perform batch updates, passing the transaction for inserting, removing, reloading sections or items within the collection view. It's pretty simple in theory, but in reality, no matter how careful we are, there's always a possibility that exception will occur, especially if we have many methods that mutate the data source and list asynchronously. The root of the problem is because the data source and UI are out of sync. The collection view and data store have their own source of truth. Although, with a good centralized update and diffing strategy, such as using Swift collection diffing or third-party libraries such as DifferenceKit, we can solve this problem. I believe it is better if Apple provides native solutions. You can also check my video on how to perform diffing with batch animation updates using Swift Collection Difference API from the link I provided at the description below. To solve this problem, at WWDC 2019, Apple finally introduced the new Diffable Data Source API as a single source of truth between the data source and UI in the collection view or table view. The Diffable Data Source is a brand new class that uses generic parameters for the section identifier and item identifier. Both types need to conform to hashable, so it can be used for diffing. To use it, we just need to initialize the class, passing the collection view and the cell provider closure. In the closure, we don't need to use the index path to retrieve the item identifier from the data source, as it is already provided as one of the parameters. Then, we need to dequeue and set up the cell with the data passed in the parameter. In the code block, I use the cell configuration API to dequeue the cell. You can learn about that in the first part of the series. I have provided the link to the video at the description below. To populate the data in the data source, we need to construct the Diffable Data Source snapshot, the adding section and item identifiers. Finally, we just need to invoke apply on the data source, passing the snapshot with animate difference parameter. The API will calculate the diffing based on the hashable and equatable. In Swift, the hashable inherits from equatable. After the diffing has been calculated, the API will update the collection view, animating the differences. With this approach, we can avoid the out of sync state between the UI and data source, as the snapshot is the single source of truth. If our backing store data changes, for example, after user trigger a fresh API call, we just need to construct and apply the new snapshot again. That's it for the brief summary of Diffable Data Source and Snapshot. Let's move on to implement this by replacing the current UI Collection View Data Source implementation to use the new Collection View Diffable Data Source API. Now, navigate to the extension of Character List View Controller, where we implement the UI Collection View Data Source protocol. We just need to select all of this code and remove it. And navigate to the Setup Collection View here and remove this line. Okay, now let's navigate to the top of the source file and let's declare a property named data source. The type will be UI collection view diffable data source. And here we have to provide two generic parameters. The first one is the section. In this case, we're going to use the section struct for the identifier. And for the second parameter, it's going to be the item identifier. In this case, we are going to use the character struct. And let's set it as implicitly unwrapped optional. And now we're going to create our private method named setup data source. And let's add the invocation to this method inside v.load here below the setup bar items. Setup data source. Now let's move on to implement the setup data source method. First, we need to initialize the data source property with UICollectionViewDataSource here. We're going to use this initializer. We need to pass the collection view instance as well as the cell provider closure. The closure pass three parameters: collection view, index path, and the last parameter is the item identifier. In this case, it will be the character struct. And the return type is the UI collection view cell. So basically, here we need to the queue and return the cell. Let's set the view controller as weak here. And let's check it first. If it is nil, we just return nil. And now let's dequeue the cell using the collection view. The queue configured traceable cell. We're going to pass the cell registration as well as the index path. And for the item, we can just pass this character. As you can see, we don't need to manually retrieve the character from the array, as the closure already passed the character instance for us. So at last, we just need to return the cell. Okay, as you can see here on the list, we have a supplementary header view for each section. We also need to provide this to the data source using the supplementary view provider property, and we need to assign it with a closure. There are three parameters: collection view, the element kind, header or footer, and the index path. The return type will be UI collection reusable view. Okay, let me set the view controller switch first, and then I'm going to check here. Single statement. If it is nil, I just return UI collection reusable view placeholder. And then to continue, we're going to dequeue the header view using collection view, the queue configured reusable supplementary. I'm going to pass the header registration and the index path. And finally, I just need to return the header view. Next, navigate to this header registration. And as we are using the Diffable Data Source and Snapshot to drive the collection view data, we won't be accessing the data from the backing store array, as it can be out of sync. So let's navigate here and declare a private method named setup configure header view. First parameter is the header view with type of UI collection view with cell, and the second parameter will be the index path. How do we retrieve the section identifier and item identifier in the Diffable Data Source snapshot? It is actually pretty simple. First, let's retrieve the character. We can use the data source item identifier passing the index path, and let's retrieve the section that belongs to the character. using the data source.snapshot section identifiers containing the character. Okay. If one of them is null, you can just return. And now we need to retrieve the total characters inside the particular section. We can use the data source.snapshot item identifiers in section, passing the section. This will return the array of character in that section. So we can just use the count here. And now we need to configure the header view. We're going to use the content configuration API. Declare a var here, content, and header view default content configuration. For the text, we are going to use the text property, and we can use the section dot header title text, passing the count. And at last, we need to assign the header view content configuration with the new content. Okay, that's it for the configure header view method. Now let's navigate to the header registration here, and let's replace this. First, we need to make the view controller as weak here. Going to check here. If it is nil, we just return. And at last, we can invoke the configure header view, passing the header here as well as the index path. Okay, now let's move on to implement the setup snapshot method. Declare a method named setup snapshot with one parameter, array of session characters tuple. In this method, we are going to construct the snapshot from the section characters tuple array and apply the snapshot to the diffable data source. Before we forget, just add the invocation here in the viewDidLoad method below the setup data source, setup snapshot, and for the store, let's pass the decking store property. In the setup snapshot implementation, first we need to declare a property name snapshot and initialize a NS Diffable Data Source snapshot. There are two generic parameters, section and character struct. Okay. And next we need to loop the store array using the for each. Okay. First, let's destructure the tuple and assign them into a property. Section, characters. And now we need to append the section using the append sections method in the snapshot. And next, we need to append the items inside the section. We are going to append the characters to the section. Okay. And finally, we need to invoke the data source dot apply, passing the new snapshot. And for the animating differences, let's pass through here so we can get the animation. Now let's try to build and run the app. I'm going to run it using the Shift UI Live Preview here. So let me build and click try again here. Okay, there's an error here. Looks like it cannot find the section. I think, yeah, there's a name placing between modules because Shift UI also has a section struct. So let me explicitly use the or module characters grid.section. Okay, it works now. Let me switch between universe. It doesn't work, right? So let's see why. Here, as you can see, we are using the collection view reload data. With the new Diffable Data Source snapshot, we cannot invoke collection view reload data or perform batch updates. So basically, we need to use we need to call the snapshot again, passing the new backing store. Okay, this will construct the snapshot and apply it, animating the differences. Okay, let's try it. Okay, yeah, it works, but yeah, if you see there is no animation here. Why? Because all the section and items have different hash values. The collection view will reload all the content in the list without animating the differences. Next, let's add a shuffle feature so we can shuffle the position of the characters in the section. With this, we should be able to see the animation when the item moves from the old position to the new position. Okay, here I already provided two bar buttons items. The right one is the shuffle button, and the left one is to refresh the backing store to the initial data. Let's implement the shuffle tab first. So basically, to shuffle the backing store, we can just invoke backing store.map. Here we will transform this, but we will transform to the same closure. But in this case, for the characters, we're going to call shuffle. This will returns the element of the sequence shuffled. Okay, and we are going to assign it to the backing store. And we can just invoke the setup snapshot, passing the new backing store. And for resetting the data to the initial store, we can just retrieve selected the segmented control selected universe dot section stubs, and we can also make sure to call the setup snapshot passing the backend store. Okay, let's build. Click on resume here. Okay, let me try the shuffle button. Nice. Wow, the animation is so smooth. Let me also shuffle the section here, the animation between section. Okay, nice. Wow, this is pretty amazing, right? Now let's reset the data to the initial bashing store. Nice. It works. Now, for the final part of this video, I'm going to add a search feature using Combine. If you never used a reactive framework like RxSwift or Combine before, this will be a great introduction to you. I won't be covering too much though, as Combine itself is pretty huge and complex. In the future, I will create a Combine from scratch series tutorial videos. So stay tuned and subscribe to this channel. First, we need to declare the setup search bar method. Let's declare it below the setup bar items. Setup search bar. First, we need to initialize the search controller. UI search controller. Pass nil for the search controller parameter. I will be using the character list B controller to drive the results in the list. And next, we need to remove the dim view when presenting the search bar. We can use the search controller obscures background during presentation, assign it as false. Finally, set the search controller search results updater as the view controller. Next, we need to implement the UI search results updating protocol. create an extension here for the character list the controller, make it conform to the UI search results updating. There's one required method, update search results. This will be invoked whenever the user types inside the search bar. Let's leave it empty for now. Okay. Navigate back to the setup search bar here. And we need to set the navigation item search controller with this search controller. Okay. Now we need to add this invocation inside the view did load. Let's add it below the setup bar items. Okay. Now let's try to build and run. Nice. Now we have the search bar at the top. Next, we need to declare the search text string using PassthroughSubject. PassthroughSubject is a type where we can publish and observe sequence of values too. We need to import Combine framework at the top. And next, we need to declare the property name search text and assign it with PassthroughSubject. And for the generate parameters, for the value, it will be string. And for the error, we won't have any error here, so we can use this special type called never. Okay, and let's initialize it. Next, we need to declare a property named cancellables. The type will be set of any cancelable. We will store the observer reference to this set later when we set the observer. Next, we need to handle the publishing of new value whenever the user types on the search bar. To do this, we need to navigate to this update search results inside the UI search results updating protocol. And then we're going to use search text.send. And for the string, we can access it from the search controller.searchbar.text. This is an optional, so let's provide the default value of empty string. For the observer handling, we need to declare a new method called setup search text observer here below the setup search bar. And make sure to invoke this after the invocation to setup search bar in view did load. With the search text PassthroughSubject, we can observe the stream of values whenever they are being published using combine operators. The first operator that we are going to use is the debounce operator here. Let's use the milliseconds, passing 100. And for the scheduler, we can use the main run loop. With this, we will make sure to wait if there are no other additional characters typed by the user until 100 milliseconds before the value is received. This is very useful for the search bar, as we don't want to filter every character that the user types. Next, we are going to change the results using the next operator, which is map here. In this case, I want to convert the string to be lowercase. And at last, we can use this sync operator to receive the value. Here we can provide our own logic. If the search text is empty, I'm going to first let me declare the weak self for the V controller here and make sure it's not nil before we proceed. If the search text is empty, I'm going to invoke self setup snapshot, passing the backing store. Otherwise, I'm going to filter the characters in the section. Let's declare a property and filter sections. I'm going to use the backing store. and invoke it with map here. I'm going to return the same closure, but I will filter the character with the search text. I'm going to use the filter here and make sure the name contains the search text. I'm going to lowercase the name first. Okay. And that's it. With this, we are going to filter the characters in each section using the search text. And I'm going to filter this to make sure there is no empty characters in the section. Okay. Now let's call the setup snapshot, passing the filtered section. It's the store. Okay. That's it. And make sure to call store here to store this observer inside the cancellables property that we declared previously. Okay, now let's try to build and run the app to try this. Let me type A. Nice. The characters are filtered. A, T, I, C, L. Okay, nice. Let's cancel. Yes, the list is being reverted back to its original decking store. But if you see closely here, there's a problem with the number of characters in the section. It is not being updated. We need to handle this by reloading all the visible headers after the snapshot has been applied. So let's do this. Let's declare a private method named reload headers below the configure header view method. First, we're going to retrieve all the index path of visible headers. We can use the collection view index path for visible supplementary elements of kind. In this case, we're going to use the element kind section header. Okay, this will returns the array of index path, and we can use for each here. And basically, here we need to retrieve the header. We can use the collection view supplementary view for element kind, passing the element kind section header and the index path here. And let's cast this as UI collection view is cell. If we cannot find it, just return. And at last, we can invoke configure header view, passing the header view as well as the index path. Okay. And we need to invoke this inside the setup snapshot. Okay, let's find setup snapshot. Here in the data source.apply method, we can add additional parameter completion. It accepts a closure here. In this case, we can pass the reload headers method. Okay. Okay, now let's try to build and run again to make sure it fixes the problem. Let's search for A. Okay. Avalanche 3, Genova 2, Sandra 2, A. Okay. 1. And let's try CL1, 1 and 1. Okay. We fixed the problem by reloading the headers after the snapshot has been applied. That's it for this video. We can see that with the Diffable Data Source API, handling data source changes with perfect animation diffing is pretty simple to do. No more index path based API that can cause crash when the backing store array is out of sync with the UI. Snapshot will be the single source of truth. For any data updates, we just construct the new snapshot from the backing store and apply it to the data source. The diffing and animation will be automatically provided by the system. If you are interested to learn more about this, you can watch the DuckDuckDC 2019 video, Advances in the Data Source, from the link I provided at the description below. In the next video, we're going to add the editing feature to the collection view using edit mode, swipe to the left, reordering handlers, and adding checkmark accessory for the selected characters. So stay tuned and subscribe to the channel. Keep the lifelong learning goes on, and bye!